Good morning, good afternoon, good evening. Now we're going to explain something. I want to share some about this book. This title says, This Explains Everything, edited by John Bruckmann. Deep, beautiful, and elegant theories of how the world works. This everything explains. Let's see what happens. We can make a difference, even though if you do something different, of course, something gonna change in your life. Remember, you have a purpose in this life. For some reason, you just listen this. Nothing is coincidence. Acknowledgements. I wish to thank Peter Howard of HarperCollins for his encouragement, and I'm also indebted to my agent, Max Bruckmann, who saw the potential for this book, and to Sarah Limpcourt for her thoughtful and meticulous editing. Preface. The Age Question. In 1981, I founded the Reality Club. From its founding through 1996, the club held its meetings in Chinese restaurants, artist lofts, the boardrooms of investment banking firms, ballrooms, museums, and living rooms, among other venues. The Reality Club differed from the Algonquin Round Table, the Apostles, and the Bloomsbury Group, but it offered the same quality of intellectual adventure. Perhaps the closest resemblance was to the late 18th and early 19th century Lunar Society of Birmingham, an informal gathering of the leading cultural figures of the new industrial age: James Watt, Erasmus Darwin, Josiah Wedgwood, Joseph Priestley, Benjamin Franklin. In a similar fashion, the Reality Club was an attempt to gather together those people exploring the themes of the post-industrial age. In 1997, the Reality Club went online, rebranded as Edge. The ideas presented on Edge are speculative. They represent the frontiers in such areas as evolutionary biology, genetics, computer science, neurophysiology, psychology, cosmology, and physics. Emerging out of this contribution is a new natural philosophy, new ways of understanding physical systems, new ways of thinking that call into questions many of our basic assumptions. For each of the anniversary editions of Edge, I and a number of Edge stalwarts, including Stuart Brand, Kevin Kelly, and Joe Dyson, get together to plan the annual Edge questions, usually one that comes to one or another of us, of our correspondents, in the middle of the night. It's not easy coming up with a question. As the late James Lee Byers, my friend and sometime collaborator, used to say, I can answer the question, but I am right enough to ask it. We look for questions that inspire unpredictable answers, that provoke people into thinking through they normally might not have. For this year's questions, our thanks go once again to Steven Pinker. Perhaps the greatest pleasure in science comes from theories that derive the solution to some deep puzzles from a small set of simple principles in a surprising way. These explanations are called beautiful or elegant. Historical examples are Kepler's explanation of complex planetary motions as a simple ellipses, Niels Bohr's explanation of the periodic table of the elements in terms of the electron shells, and James Watson and Francis Crick's explanation of genetic replication via the double helix. The great theoretical physics, Dirac famously said that it's more important to have beautiful in one's equations than to have them fixed experiment. The Edge Question 2012. What's your favorite deep, elegant, or beautiful explanation? The online response to the Edge website this year was enormous, some 200 proactive and often lengthy discussions. What follows is necessarily an editor-led selection. In the spirit of Edge, the contribution presented here embraces scientific thinking in the broadest sense, as the most reliable way of gaining knowledge about anything, including such fields of inquiry as philosophy, mathematics, economics, history, language, and human behavior. The common truth is not a simple and non-obvious idea. It's proposed as the explanation for a diverse and complicated set of phenomena. John Brockman, publisher, editor, Edge. Evolution by means of natural selection. Susan Blackmore, psychologist, author, Consciousness and Introduction. Of course, it has to the Darwin. Nothing else comes close. Evolution by means of natural selection, or indeed any kind of selection, natural or unnatural, provides the most beautiful, elegant explanation in all of science. This simple three-step algorithm explains, with one simple idea, why we live in a universe full of design. It explains not only why we are here, but why trees, kittens, Urdu, the Bank of England, Chelsea football team, and the iPhones are here. You may wonder why. If this explanation is so simple and powerful, no one thought of it before Darwin and Alfred Russel Wallace did. And why even today so many people fail to grasp it? The reason, I think, is that at its heart there seems to be a tautology. It seems as though you are saying nothing when you say that things that survive, or successful ideas are successful. To turn these tautologies into power, you need to add the context of a limited world in which not everything survives and competition is rife. And also realize that this is an ever-changing world in which the rules of the competition keep shifting. In that context, being successful is splitting, and now the three-step algorithm can turn tautology into deep and elegant explanation. Copy the survivors many times with slight variations and let them loose in this ever-shifting world. And only those suited to the new condition will go wrong. The world fills with creatures, ideas, institutions, language, stories, software, and machines that have all been designed by the streets of this competition. This beautiful idea is hard to grasp, and I have known many university students have been taught evolution at school and thought they understood it, but never really done so. One of the joys of teaching for me was to see that astonished look on students' face when they suddenly got it. That was heartwarming indeed. But I also call it heartwarming because, unlike some religious folk, when I look out of my window past my computer to the reach over the river and the trees and cows and distance, I delight in the simple and elegant competitive process that brought them all into being, and at my own tiny place with it all. Life is a digital code. Matt Riddle, science writer, founding chairman, International Center for Life, author, The Rational Optimist. It's hard now to recall just mysterious life was on the morning of February 28 and just how much that had changed my lunchtime. Look back at all the answers to the questions. What's life? From before that, and you get a taste of just how we, as a species, floundered. Life consisted of three-dimensional objects of specificity and complexity, mainly proteins, and it copied itself with accuracy. How? How do you set about making a copy of three-dimensional object? How do you grow into and develop it in a predictable way? This is the one scientific question whose answer absolutely nobody came close to guessing. Erwin Schrödinger had a sad but fell back on quantum mechanics, which was irrelevant. True, he used the phones, a periodic crystal, and if you are generous, you can see that as a prediction of a linear code. But I think that's a stretch in generosity. Indeed, the problem had just got even more daunting thanks to the realization that DNA played a crucial role, because DNA was monotonously simple. All the explanation of life before February 28, 1953 are hand-waving, waffle, and maybe as well have spoken of photoplasm and viral sparks for all the insight they gave. Then come the double helix, and the immediate understanding that Francis Crick wrote to his son a few weeks later. Some sort of code, digital, linear, two-dimensional, combinatorial, infinite, and instantly self-replicating was all that explanation you needed. Here is part of Crick's letter. March 17, 1953. My dear Michael, Jim Watson and I have probably made the most important discovery. Now we believe that the DNA is a code. That is, the order of the bases, the letters, makes one gene different from another gene. Just as one page you print is different from another. You can see how nature makes copies of the genes. Because if the two chains unwind into the two separate chains, and if each chain makes another chain come together on it, then because A always go with T, a G with C, we shall get two copies where we had one before. In other words, we think we have found the basic coping mechanism by which life comes from life. You can understand we are excited. Never has a mystery seemed more fluffing in the morning and an explanation more obvious in the afternoon. Redundancy reduction and pattern recognition. Richard Dawkins, evolutionary biologist, emeritus professor of the public understanding of science, Oxford, author of The Magic of Reality. Deep, elegant, beautiful. Part of what makes a theory elegant is its power to explain much while assuming little. Here, Darwin's natural selection wins hands down the ratio of the huge amount that it explains everything about life, its complexity, diversity, an illusion of crafted design divided by the little that it needs to postulate non-random survival of randomly varying genes through the geological time is gigantic. Never in the field of human comprehension were so many facts explained by assuming so few. Elegant then, and deep, its depths hiding from every day until as late as the 19th century. On the other hand, for some tastes, natural selection is too destructive, too wasteful, too cruel, to count as a beautiful. In any case, I can count on somebody else choosing Darwin. I'll take his great-grandson instead, and come back to the Darwin at the end. Horace Darwin is the youngest grandchild of Sir Horace Darwin, Charles Darwin's youngest child. Now a very active knighted, Barlow is a member of distinguished lineage of Cambridge neurobiologists. I want to talk about an idea he published in 2 papers in 1961 on a redundance reduction and a pattern recognition. It's an idea whose ramification and significance have inspired me throughout my career. The folklore of neurobiology includes a mythical grandmother neuron, which fires only when a very particular image, the face of Jerry Ledvin's grandmother, falls on the retina. Ledvin was a distinguished American neurobiologist who, like Barlow, worked of the frog retina. The point is that Ledvin's grandmother is only one of countless images that a brain is capable of recognizing. If there were a specific neuron for everything we can recognize, not just Ledvin's grandmother, but lots of the other faces, objects, letters of the alphabet, flowers, each one seen from many inches of distance, we will have a combinational explosion. If sensory recognition worked on the grandmother principle, the number of specific recognition neurons for all possible combinations of nerve impulses would exceed the number of atoms in the universe independently. The American psychologist Fred Adniva had calculated that the volume of the brain would have to be measured in cubic light years. Barlow and Adniva independently proposed redundance reduction as the answer. Redundance reduction as the answer. Claude Shannon, inventor of information theory, coining redundance as a kind of inverse of information. In English, Q is always followed by U, so the U can be omitted without loss of information. It is redundant. Wherever redundancy occurs in a message, which is wherever there is non-randomness, the message can be more economically recorded without loss of information, although with some of loss in capacity to correct errors. Barlow suggested that every stage in sensor pathways there are mechanisms tuned in to eliminate massive redundancy. The word at time t is not greatly different from the word at the t1. Therefore, it's not necessary for sensory systems continually to report the state of the world. They need only sign change, leaving the brain to assume that everything not reported remains the same. Sensory adaptation is a well-known feature of the sensory systems, which it does precisely as Barlow prescribed. If a neuron is signaling temperature, for example, the rate of firing is not, as one may naively suppose, proportional to the temperature. Instead, firing rate increases only when there is a change in temperature. It then dies away to a low, resting frequency. The same is true of neuron signals, brightness, loudness, pressure, and so on. Sensory adaptation achieves huge economies by exploring the non-randomness in temporal sequence of states of the world. What sensory adaptation achieves in the temporal domain? The well-established phenomenon of lateral inhibition does in the spatial domain. If a sense in the world falls on a pixelated screen, such as the back of a digital camera or the retina of an eye, most pixels seem the same as their immediate neighbors. The exceptions are those pixels which lie on edge boundaries. If every retinal cell faithfully reported its light value to the brain would be bombarded with a hugely reductant message. Great economies can be achieved if most of the impulses reaching the brain come from pixel cells lying along edge in the scene. The brain then assumes uniformity in the spaces between edges. As Barlow pointed out, this is exactly what lateral inhibition achieves. In the front retina, for example, every ganglion cell sends signals to the brain, reporting on the light intensity in its particular location on the surface of the retina, but it is simultaneously sends inhibitory signals to its immediate neighbors. This means that the only ganglion cells to send strong signals to the brain are those that lie on an edge. Ganglion cells lying in uniform fields of color, the majority sends few any impulses to the brain, because they, unlike cells on edges, are inhibited by all their neighbors. The spatial redundancy of the signal is eliminated. The Barlow analysis can be extended to the most what is now known about sensory neurobiology, including Hubble and Weiser's famous horizontal and vertical line detector. Neuron its cut straight lines are redundant, reconstructible from their ends, and in the movement back detectors in the fog retina, discovered by the same Jerry Ledbing and his colleagues. Movement represents an redundant change in the frog's world, but even movement is redundant, it persists in the same direction and the same speed. Sure enough, Ledbing and colleagues discovered a strangeness neuron in the frogs, which fires only when a moving object does something unexpected, such as speeding up, slowing down, or changing direction. The strangeness neuron is turned to filter or redundance of a very high order. Barlow pointed out that survey of the sensory effects of a given animal called, in the theory, give us a real doubt of the redundancies present in the animal's world. They would constitute a kind of description of the statistical properties of that world, which reminds me, I return to Darwin in Unwaving the Rainbow. I suggested that the gene pool of species is a genetic book of the dead, a coded description of the ancestral worlds in which the genes of the species have been surviving throughout geological time. Natural selection is an average computing, detecting redundancies, repeat patterns, in successive worlds successive through millions of generations in which the species has survived, average over all members of the sexually reproducing species. Could we take what Barlow did for neurons and sensory systems and do a parallel analysis for genes in natural selected gene pools? Now, that would be deep, elegant, and beautiful. The power of absurdity. Scott Train. Anthropology, Center National Research, Scientific Parties, author taking to the enemy, Fate, Brotherhood, and the unmaking of the terrorists. The notion of a transcendent force that moves the universe of history, determines what's right and good, and whose existence is fundamentally beyond reason and immune to logical or empirical disproof, or the simplest, most elegant, and most scientifically baffling phenomenon I know of. Its power and absurd imperators mighty and merits careful scientific scrutiny. In an age in which many of the most volatile and seemingly intractable conflicts stem from sacred causes, scientific understanding of how best to deal with the subject has also never been more crucial. Call it love of group or God, or devotion to an idea, or cause in matters little in the end. It's the privilege of absurdity to which no living creature is subject, but man only, of which Jehovah's roaring Leviathan in the desert of men. Darwin cast it as the virtue of the morality, with which winning tribes are better endowed in history, spiraling competition for survival and dominance. Unlike other creatures, humans define the groups they belong to in abstract terms. Often they strive to achieve a lasting intellectual and emotional bond which anonymous others and seek to heroically kill and die, not in order to preserve their own lives or those of people they know, but those for the sake of an idea, the conception they have formed of themselves, of who we are. Sacred or transcendental values and religious ideas are cultural universal, yet context varies markedly across cultures. Sacred values mark the moral boundaries of societies and determine which material transactions are permissible. Material transgressions are the sacred or taboo. We consider people who sell their children or sell out their country to be sociopaths. Other societies consider adultery or disregard of the poor immoral, but not necessarily selling children or women or denying freedom of expression. Sacred values usually become strongly relevant only when challenged, much as food takes on overwhelming value in people's lives only when denied. People in the cultural millennium are often unaware of what's sacred for another, or in becoming aware through conflict, find the other side value pro-life versus pro-choice, seizing more and absurd. Such conflicts cannot be wholly reduced to secular calculation of interests, but must be dealt with on their own terms. A logic different from the marketplace or real politics, for example. Cross-cultural evidence indicates that the prospect of a crippling economy, burdens, and huge numbers of deaths doesn't necessarily spy people from choosing to go to war or to opt for a revolution or resistance. As Darwin noted, the virtuous and brave do what is right, regardless of consequences, as morally imperative. Indeed, we have suggestive neuroimaging evidence that people possess sacred values in parts of the brain devoted to rule-bound behavior rather than utilitarian calculations. Think Ten Commandments or Bill of Rights. There is an apparent paradox underlying the formation of large-scale human societies. The religious and ideological rise of civilization of large and large agglomerations of genetic strangers, including today's nation, transnational movements, and other imagined communities of fictive kings seem to depend upon what Kierkegaard deemed this power of the preposterous, as in Abraham's willingness to lead the throat of his most beloved son to show commitment to an invisible, no-name deity, thus making him the world's greatest culture hero rather than a child abuser, would be murdered or psychotic. Humankind's strong social bonds and actions, including the capacity for cooperation and forgiveness, and for killing and allowing oneself to be killed, are born of commitment to cause and courses of action that are ineffable. That's fundamentally immune to logical assessment, for consistency and empirical evaluation for cost and consequences. The more materially inexplicable one's devotion and commitment to a sacred cause, that is, the more absurd, the greater trust other place in and the more than trust generates commitment on the part. Okay. I just shared this a little bit. Remember, everything happens for a reason. Have a blessed day and be different. You can change the world when you decide to do it. Bye-bye.